today is 5.6, okay? So this is just applying some formulas that use exponentials, okay? So real life stuff. This is when we use exponentials, okay? So we're gonna start off with exponential growth and exponential decay. Hopefully you've seen this before. I think you guys talk about it in personal finance a little bit. Yeah? Yeah, we've maybe seen it. It was freshman year? Oh, that was so long ago. Sophomore year? That wasn't very long ago. Some of you guys are sophomores. You don't remember it? Gosh, okay. Well, it's gonna hopefully come back to us then. So we'll start off with exponential growth. Wow, can't talk. Write this down. F of t equals a parentheses 1 plus r close parenthesis to the t power. Okay? A is going to stand for your initial amount of whatever is growing. Okay? Hopefully money, right? We like for money to grow. And then R is going to represent that growth rate. T is going to be time. Pretty straightforward. Okay, so for instance, number 1 says the original value of an investment is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation. Then find the value after 15 years. Okay, you'll notice how I underlined the things I thought were important. Okay, that just makes it easy. Now I just go plug them in. So f of t, what's my time here? 15 years. So f of 15 is going to equal, A is my initial amount, so that's going to be my initial investment of $1,800, times 1 plus my growth. This is the one thing you do have to remember on this. Growth rate has to be converted to a decimal. So if I have 7%, that's actually going to be, 0.07. Close parenthesis to the 15 power, because again we said t was 15. Now I just type this whole thing in my calculator, and it should give me the answer. Tell me what you got. What did we get? 0.3 what? 0?
I rounded that up. It's 0.256, so I rounded it up.
Let's do money though, since this is dollars. So 0.256 would be 0.26.
Yeah.
Okay, cool. You didn't get that, so let's look at what you typed in. Guys, make sure we type the decimal in right, okay? That is the big thing to remember, is that we do have to watch that, okay? But we got that one, so good deal. Next one, I want you to go ahead and try that. Okay, how we set this up? Okay, so in 2002, there were 972 students, increased by 1.5%. Write a function. So how'd you get f of 12? How'd you get time of 12?
2 to 14 minus 2.
Yeah, it didn't tell me how many years. It just asked how many years have passed since 2000, or from 2002 to 2014. So you just have to subtract 2014 minus 2002, and you get 12. So f of 12 equals my initial amount is times 1 plus 0.015, close parenthesis, to the 12. And what'd you get? 1,162. Why'd you round to a whole number? You can't have 0.1 of a person, I would agree, okay? So a lot of these scenarios, it's going to depend on what it's asking you for rounding. So for instance, if it's money, always round to 2 decimal places. If it's something like people or cars or something like that, you can't have a half of or a decimal of, just round to the whole number. If it's something else, then just kind of use your own judgment, okay? Unless it tells you what to round to. So 1,162 students would be what I labeled that. Okay, exponential decay is going to be very, very similar, okay? The formula is almost identical with one thing different. F of t equals a times 1 minus r to the t power. So almost the same thing, the A still stands for initial amount. The R still stands for growth, and T still stands for time. Okay? So it says an investment of $12,000 is losing value at a rate of 4% each year. Write an exponential function to model the situation. Find the value after 9 years. So underlining the important things and then just plugging them in. T is going to be what on this one? 9. So f of 9 equals my initial investment, they told me was 12,000, times 1 minus my rate of 4%, which would be 0.04, right? Don't put 0.4, that would be 40%, to the 9th power. Yep, type it in. Type it in, tell me what you got. 831. 8310. 8,310 and how many cents?
That's 831. That's what I got. That's 831.
Let's look. Did you type the decimal in right?
Yeah.
Did you get it to, you what? You wrote 1,200. Okay, that explains it. Okay, everybody get this? Okay, so honestly the hardest part about this is just typing it in the calculator right. We figured out. Would you agree? Okay, not too crazy. We're actually going to skip number 4, but before we move on to the next page, when you get to your homework and your test on this, okay, and the EOC, number 1, I'm going to give you the formulas for the test, and the EOC is going to give you that formula, okay? It's going to give you both. You just have to make sure when you're taking the EOC, if you see a question like this, you recognize that it says to set up an exponential function, and you go look at your formula sheet, right? And you look for exponential growth or decay. Here's the deal, though. I and the EOC am not going to tell you whether it's exponential growth or decay. You have to be able to tell that from the problem. So let's look at number 1. What's a key word that's going to tell you that that was growth and not decay? Yeah, the word increase, okay? Same thing on number 2. It used the word increased. What about number 3? Losing value. And number 4, we didn't do it, but it said the word depreciate. That's the same thing as losing value, okay? So make sure we can tell with those words which formula to use. Are you with me? Okay. Cool. Next one, we've got compound interest. Compound interest. We've definitely seen this one before in personal finance if you've been in that class, which I think we all have. A equals capital P, parentheses, 1 plus R over N, close parentheses, to the NT power. Again, not expected to memorize that formula. You just have to know how to use it, okay? So P is going to represent what we call principal, which is the same thing as just your initial amount, okay? So instead of lowercase a, it's capital P, means the same thing. R is still going to be growth, and it still needs to be in a decimal. Don't plug it in as a percent or you're going to get it wrong. Okay, lowercase n, this is a new one. This means number of times your principal is compounded every year. So we'll write yearly or annually. Okay, so the number of times that it's compounded yearly. Keyword is yearly, so make sure you write that. And then last but not least, we got time in years. Got that down? Okay. So we'll read through number 5. It says Laura deposited $12,000 in an account, earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? Okay, I don't know what A is yet, but I do know that my principal or my initial amount was 12,000 times 1 plus my growth is 0.08, 8% is 0.08, divided by N, which is going to be the number of times that this was compounded yearly. Well, it said it was compounded quarterly, which means 4. Good, so this means that N's going to be 4 if it says quarterly. That was a really weird arrow, I'm sorry. Okay, 4. And then lastly to the NT power. So we said N was 4 times T, which is 5. Okay? So this is the same thing as 12,000 times 1 plus 0.08 divided by 4 to the, what's 4 times 5? 20 to the 20th power. So go ahead and type that into your calculator just like that. Just like that. Say what?
17,831.37.
Okay, round it. Did everyone get 17,831 and 37 cents? Did everyone at least try it?
Sure.
Carter,
What?
don't get sassy. Okay. Questions on that? How do we feel? Okay, good. Let's try number, let's do number 7, okay? This one says semi-annually, which means how many times a year? Twice, 2 times. So go ahead and try that one. Okay, how'd you set this one up? What'd you write for your formula? All right, let's do one person. Who wants to go? Madison, you do this one. 4,000 times what?
1 plus 0.09 divided by 2 to the 24th power.
So 0.039, you said? Divided by 2 to the 24th power, because it was 2 times 12, which is 24. And then what'd you get for that?
6358.48.
Cool. All right, are we good to go on that one? Okay, we're actually going to skip over the rest, but before we do, I do want to real quick just talk about what would N equal on number 6? How many times would that be compounded if it said compounded monthly? Yep, N would be, no.
Bi-monthly this time?
No, number 6.
12.
Monthly would be 12. You're looking at number 8. So 8 says bi-monthly, which would be how many times a month? Did someone just say 6? No. Bi-monthly would be twice a month, right?
24.
So it'd be 24. There would be a little confusion on that though, because I could see how you would think it would be every other month, okay? So I don't know if that's on the test, but we'll look and see before we take that test, okay? So bi-monthly N would be, I'm going to call it 24, because I do think it's twice a month. Okay, and then lastly, 9. It says compounded weekly. What would N equal if it was compounded weekly?
52.
52, because there are 52 weeks in a year. Okay, cool. All right, so listen up, listen up, listen up. This is important, okay? So when you see a question, just like the ones we just did, and it told you, okay, it told you that the interest was compounded, okay? You always use the compound interest equation, correct? Okay. However, if it says that it is continuously compounded, okay, which means that every single month it's compound, or whatever the time is, it's compounded continuously, okay, which means it's going to grow a little faster. It's going to tell you in the word problem. It's going to use the word continuously. So you'll never have to guess between the two, okay? If it says compounded, it just means compound interest. But if it says compounded continuously, then it's this one, okay? It's a very similar formula, but you'll notice, what letter is this? E, the base of E, I told you that that was used for real life problems, right? Here we go. Here's one of those scenarios. So, we'll go ahead. Tim invested $4,000 at 3% interest, compounding continuously. How much money will she, a girl named Tim, I guess, I don't know if that's a typo or if it was supposed to be like that. Anyone in here have a mom named Tim or an aunt or anything?
My aunt.
Your aunt's name is Tim?
Yeah.
And it's a female?
Yeah.
Okay, I'm sorry.
Oh, sorry.
Okay. I'm kidding. I'm kidding. Okay. Cool. I want to meet her. All right. After 4 years though, right? So we're going to go ahead and plug this in. So A is going to be our final amount. Principal for this one would be what? 4,000. Put the letter E. My interest rate would be what? 0.03 times time, which is 4. Okay, just type that into your calculator exactly like that. Round it to 2 decimal places because again we're talking money. Yeah, we are. Carter's always talking money. For real. What'd you get? So second natural log if you're using one of my calculators. Yep. Second natural log, you'll get that letter E. What did we get? One person. What'd you get, Catherine?
4,509.98.
You rounded it to 99? Okay. Either way, I won't count it off if it's 1 cent. But is that what everyone got?
Yeah.
All right, cool. Pretty good investment, right? 4 years making $500 off of $4,000. Not bad. Not bad. I've done worse in the stock market before. Okay. Number 2 then. Okay. Instead of money this time, we're talking about bacteria. Gross. Okay. Go ahead and set this one up. Be careful on this one because it's saying how much bacteria can we grow in 2 weeks. Okay, so let's set this one up. How do we start it? A equals.
That's as far as I got.
0.5.
Yep, 0.5 would be your initial amount. E to the 0.1 times. What did it tell you for time? 2. 2. Okay, but here's the thing though that's confusing about this one and the reason I don't like this question is when we are dealing with compound interest, time has to be in years. So if it was 2 weeks, how would you actually convert that to years? Yeah. So think about 2 weeks out of a year, what, 2 over 20, 1 out of 26 or 2 over 52, right? Which is simplified to 1 over 26, okay? So type that in and now see what you get. That is one you got to be careful on. The other ones will work like exponential growth, exponential decay. T doesn't have to be in years. It could be in anything, okay? But for this, it does. Okay, I'm gonna round it. I got 0.5. Or like 0.502, I guess, would be a better one. So it didn't really grow very much. Kind of a weird question. I don't love it, but okay. All right, next up, we have half-life formula, okay? Another sciencey kind of thing. So if you want to be a biologist or is it a chemist? If you like chemistry, right? Yeah, does anyone want to do that in here? No? Okay. Well, if you ever change your mind, we're doing some science today. You're welcome. Okay. N of T equals N sub 0, which is going to be your initial quantity, times 1/2 to the t, which is time, divided by half-life. Okay, that's what t sub 1/2 means. It's just the half-life that it has. Okay, please stop talking over me again. I'm losing my voice. I can't yell. Okay, so example 1. We got isotopes of cesium. Okay, I think that's like an element on the periodic table. I should probably double check that though. Again, I'm not a science teacher, but I'm trying to be, okay?
Yeah.
Cesium, cesium, cesium. Cool, I said that wrong last time. Okay, so here we go. Half-life of 30 years. That could be important. 1 gram is what we're starting with. Over a period of 90 years, how many grams are going to remain? So, N of t, which my time is going to be what? 90. Equals N sub 0, which is my initial quantity. We said that's just 1.0, right? Or 1 times 1/2 to the t divided by half-life of t. So we said time was 90 and the half-life time they said was 30. What is 90 divided by 30? 3. So you're literally telling me this is just 1 times 1/2 to the 3rd power? Or just 1/2 to the 3rd power? Yeah, it is. Tell me what that is. Yep, 1/8 or 0.125, you say?
Sure.
Cool, either way you put it. I don't care if you give me a fraction, I don't care if you give me a decimal. Either way, it's the same thing. Grams, G. Cool? All right, go ahead and try number 2. We're almost done today. Certain isotype has a half-life of 6 days. How long will it take for a 100-gram sample to decay so that only 5 grams are left? This one's a little different. Okay, how'd you set this one up? N of t, quantity of substance remaining. Did they give me that? It says 5 grams are left, right? So didn't they give me that?
Yes.
5 would be N of t equals my initial quantity, 100 times 1/2 to the t over t to the 1/2, or t 1/2. So did they give me time or half-life time? Half-life time, which was 6. They did not give me regular time. Whoa. Look at that. That's not stupid. Okay, so we need to get the exponent with its base on one side by itself. What can we not have hanging out over here? The 100. Let's divide it over. What is 5 divided by 100? 0.05. Good. Equals 1/2 to the t over 6 power. Okay. What do I do if I've got an exponent that has variables in it? I've got to set up a log. Log, what's my base? 1/2 is my base of, what's on the other side of the equal sign? 0.05 equals t over 6. And now we got to solve it. So, to type in this into my calculator, it doesn't have a base of 10, right? So I've got to do log A divided by log B, which means log of 0.05 divided by log of 1/2, which is 0.5. So type that in. 4.32 equals t divided by 6. Do I have t by itself? What do I need to do? Yep, what's 4.32 times 6? 25.14. 93, we'll call it, equals t. Fun. Very fun. I liked it. Okay, we got one more page of notes when we get back, and then we're done for today. All right, so it says performance event. This might be a performance event on your test as well, maybe. Yeah, it will be, okay? Which is why we are going to do it, okay? Consider the equation to calculate compounded interest. So if it's telling us that it is compounded interest, and it's already plugged it in for us, do we have to plug it in or set up a formula? No, that's good. It set it up for us. Awesome. It says if t is measured in years, what will the value of a of t be after 4 years? What do you think you need to do? Plug in 4 for t. A of 4 equals 18,000 times 1 plus divided by to the, where'd you get 48? 12 times 4. When you type this in, what do you get?
What if I type this in and tell you the answer?
What if?
No one else say it.
Nope.
Madison, what'd you get?
No, don't tell her.
No, don't say it.
Tell me what it is.
No.
Don't tell her.
900
No.
900.
and 30.
I got 25,258.76.
What was that, Carter?
I got
25,258.76.
Yes. And if you round it, it'd be 7.7.
It would be 77.
No, whatever.
Yeah.
Yeah.
No.
Okay, and what would that be? How would you label it? What is it?
Oh,
If it's an investment,
Money.
it's money. Put a dollar sign on that. Cool.
Alright, so me and TJ can sit next to each
Ooh,
other.
that's a great question. Another test question. How long will it be to take to triple your amount? How long will it take to triple your amount? Okay, think about it. If we started with $18,000, you with me?
yeah.
We started with $18,000 and we ended with triple that amount. What is triple of 18,000?
7,000.
Triple it. How do you triple something?
It's 4,000.
54,000 is going to be your A of T. Set it equal to your equation.
Yeah.
Okay? To the 12t power, again, we don't know the t. We don't know what t is, so that's what we're solving for. Okay? Divide what? Yep, divide the 18,000 over. What is 54,000 divided by 18,000? 3 equals, parentheses, 1 plus 0.085 divided by 12. Could we simplify that? Yeah, what is 1 plus 0.085 divided by 12? One point 007 to the 12t. Okay. So now we have our base with its exponent on one side, nothing else hanging out. So we can set up a log. Log base what? Of equals 12t. Cool. Can I type this left side in my calculator? How? Log 3 divided by log 1.007 and round it. You should get 157.49
Yeah.
divided by 12. Tell me what you get. 13.124. And that is how, what is the label? If it's time, years. Okay, so then last but not least, use complete sentences to explain what each value represents. Again, just like the test question, okay? Literally all you have to do is explain number 1 and 2. So number 1, that's my amount after 4 years, right? So in 4 years, my initial amount compounded to $25,258.77. Cool. And then part 2, how long did it take to triple your amount? So if I wait 13.127 years, my money triples. Okay? You can word that however it makes sense to you. Okay? Just put it in a sentence. Incorporating a little bit of English and math today. Okay? And on test day, that will be a question.